3.3 is about function notation. With function notation, this is really in the format of y equals f of x. The function just represents the f of x. Again, all this really is just your y. Remember that we've talked about a function, and a function has to pass that vertical line test in order for it to actually exist. So even though it looks a little goofy, it's actually a pretty simple concept. For example 1, we see f of 2 when f of x equals negative 3x plus 7, or plus 5. All you're taking is that x equals 2 and subbing that into our function on the right side and plugging that x equals 2 into the x. So even though it looks like it's goofy notation, you're just subbing that in. So I have f of 2 equals negative 3 times 2 plus 7 when I can just solve that right side. You don't have to do anything with that f of x side. So I'm just simplifying this and I get 1. Now for part B, again, same concept, different function. I have x equals negative 3 this time. I'm going to take that and sub it into the x spot as well as the g of x spot. Again, not doing anything to that g of negative 3 side. I'm just leaving it how it is, and I'm just subbing into that x spot. So when I do that, I have 2 minus negative 3 plus 9. Again, just doing my simplification here. 2 plus 3 plus 9, and I get g of negative 3 equals 14. Now example 2, we're going the reverse way. We're finding the value of x so that the function has the given value. I'm already given what it actually equals, so I'm trying to figure out what value of x was plugged in. So this negative 4 is kind of like my y. So I'm subbing that into the y spot now. So I have negative 4 equals a half x minus 3. I'm just solving for my x. So from here, if I'm solving for x, I'm going to add that 3. And I get negative 1 equals a half x. Again, solving for that x, so I'm going to have to multiply by 2 to both sides. And I end up with then negative 2 equals x. So it's just the reverse way. I'm solving for x in that case. In example 1, I'm subbing that in. So for example 3, the function d of t equals 300,000 t, and that represents the distance in kilometers that light travels in t seconds. How far does light travel in 15 seconds? So my t equals 15 seconds, and I'm just taking that value and I'm subbing it into d of t. So I've got 300,000 and just subbing it into that t spot with the 15, just like I did in example 1. Then I go ahead and just calculate this, and I get d of 15 equals 4,500,000 kilometers. Now for part B, how long does it take light to travel 12 kilometers? So 12 kilometers actually ends up being my d of t, and I'm solving for that t. So it's just like example 2. So I have d of t equals 12. So 12 equals 300,000 times t, and I'm solving for t. So I'm going to have to divide by that 300,000. Do some quick calculations here because I don't know what that is off the top of my head. It'll probably be a really small decimal if that's okay. Light travels very fast. So as I get here, I get 0.00004. So 1, 2, 3, 4 zeros. Just double checking to make sure I have this down correctly. And that equals my t. So it took that many seconds to travel 12 kilometers. So again, a function isn't that scary. You're just subbing into the x value and calculating, or you're subbing into the left side and calculating for x. But now let's talk about graphing. So if you flip the page, on the graphing side of things, if you remember slope-intercept form, you could graph this linear function off of that. That's great. If you don't, we'll use a different notation. We'll use table graphing. But we'll actually talk about that y equals mx plus b further down the road in the chapter. So actually I don't want to do that. I actually want to do the table graphing. I'm sorry, erase that. Table graphing is one of those things. You could do this if it's a linear function or if it's a circle or any type of shape. A table graphing is always the best bet on how to actually graph. What we're doing with table graphing is we're creating x values ourselves and subbing them in to our equation or our function and getting those y values, those y coordinates, in order to graph my points. So I'm actually going to leave a spot here on my table for work, and then I'll have my w of x. So again, you're just picking values and subbing them in. So I always like to do a negative, 0, and a positive number. And because this is a 2/3 as a fraction, I'm going to pick that -3, 0 and 3, because I'm using that denominator. Again, the denominator was 3, so I'm going to pick -3 and +3. So then I'm just going to sub that in my H column here, and I'm just going to calculate what that is. So I have 2/3 times -3 plus 2. So then I'm going to get -1 plus 2, which gives me 1. You could just sub that right into your calculator and get that. So then I'm going to go to my graph, and I'm going to plot -3, 1. Remember, the x's are left and right, and your w of x is your y, so that's your up and down. So I have -3, 1. Now I do the same thing with the 0. I take that value and I sub it into my function. So I have 2/3 times 0 plus 2, which gives me 2. So I have a point at 0, 2. And I miscalculated w of x for -3. Silly me, you probably caught that. That's actually at 0, because 2/3 times -3 is -2. My fault. So there, just notice, just cross out that point. It's not a big deal. Let's do the same thing though with the 3, sub it in. So I have 2/3 times 3 plus 2, and I get 4. So I'm going to plot that point at 3, 4. And then I'm just going to connect my values using a straight edge. So notice I'm just using a pencil because I didn't have anything else as a straight edge, and that's totally okay. You just need to connect your points. One thing to note, I'm sorry, I actually should have extended this. Please go from one side of the graph to the other and actually extend it all the way through. So notice I'm getting my pencil back out and extending that on. So not a big deal if you screw up. Like I said, I obviously screwed up on my point. Just scratch it out and redo it. It's not a big deal. But that's our function notation. You're just picking your x values, subbing it into your function, calculating, and getting your x and y coordinates.